I'm going to start the notes for today. Um, Before we get started, we're first going to be reviewing what each quadratic, linear, and exponential functions are. If you guys remember, for exponentials and linears, we usually always look for a certain thing. So we have exponential. I remember our graph looks like this or like this. It looks like an L. So when we are looking for exponentials in terms of word problems and application problems, we always have to look for words such as decay, appreciates, depreciates, rate, any type of words like that. That means they will be exponential functions. Now, in terms of linear, a linear is something constant. So, for example, if you're making $40 an hour, that's something you will always make. Every single hour you work, you're going to be making the same amount. So, usually, when you have a fixed rate, that's usually a linear function. You also remember linear functions are lines. So that's something that you can see as linear functions. Linear function is just rate again every single time it's constant. So usually you look for rate, something like that. Slope is another word that only relates to linear functions. And lastly, we have quadratic. Pen's not working. Quadratic. That's that U shape function. It's that parabola that's usually facing up or down. Now, for this one, it's a little bit more complex, and the reason why it's a little bit more complex is because you can do a lot of things. So, for example, um, if I am a pitcher, I play baseball, and I were to hit the bat or hit the ball with the bat, the ball will go up and then eventually it will go down. So notice how it makes a parabola. So every single time we talk about quadratic, we talk about something either going up and then it will eventually come down. Whereas if you can see for linear, linear is stating that it's going to keep going up forever. So for linear, it's you can't throw a ball. No one throws a ball and it doesn't come back. It will eventually go down. So when we talk about problems like that, or we kick a soccer ball, we kick a football, it goes up and then eventually it goes down. So look for that in terms of quadratic functions. If we move on to the next page, we could be a little bit more clear. And we're going to keep going back to this page. And I'll kind of write it down towards the end and give you a PDF as to what for when you want an exponential, a linear, or a quadratic. So we look at the first problem. We always have to look for keywords. Now, keywords, at least for me, are words like depreciate and especially that percentage. When we talk about percentages, we will always be talking about exponential functions. Now, the reason why it is exponential functions, well, that's simply because that's going to be depreciating every single time. So when we try to explain, we can just write that there's a rate included in the problem. So there is a rate of 5%. Every single time we see a rate or a percentage, we will always be talking about exponential functions. If we move on to the second question, it says a ball's height as it is thrown in the air. So same thing goes here. If we are talking about a ball being thrown into the air, that ball is going to go up and then it's going to go down. Notice how it makes a quadratic function. Now, and then explanation, it just simply ball goes up. Let me rewrite that again. Let's see if it works now. Ball goes up and eventually it goes down. So again, any object you throw up in the air, it will always eventually come down. So when we're talking about a height of something or something being thrown, that's always going to be a quadratic function. If we move on, you earn $10 every week for allowance. Now, same thing goes here. Notice how we're going to be getting every week, we're going to be obtaining $10. So week 1, you have $10. Week 2, you'll have $20. Week 3, you'll have 30. You'll keep getting the same exact amount. What does that mean? This is constant. And when we have a constant application problem, it will always be linear. So we can write here that there is a rate of $10 each week. And it doesn't say it's going to change. So that is why we can conclude it is linear equations. Rate of $10 each week. So that's what would be if we are talking about a daily allowance or something you're getting every single time. If you look at the next question, it says your grandparents give you $500 for your birthday. Now, what's important here is that we're only getting $500 once. So we have those $500 and increase that amount by $4 each year. So plus $4 each year. So again, here it is important is this right here. That on the last thing, talking about every single year, we are going to be getting an amount that is the same. In this case, we have $4 each year, and it doesn't matter with those 500. Now, if you guys remember, for linear equations are y equals mx plus b, where m is the slope or our rate of change. In this case, our rate of change would be 4, and b is a constant. Constant just means that something that will always stay the same. In this case, it'd be $500. So when we are trying to explain, we can just say it has a rate of $4. Rate of $4. And we can also write it has a constant $500 for just that one time. $500 deposit. And we move on to the last question. It says you deposit $500. So here again, we have $500. But the difference between the first question and the second question is that we see the words. Well, first we see the 3%, and then it says interest compounded annually. Every single time we see a percentage, we always know it's exponential. And also, if we see interest compounded annually, anything that has to do with compound interest or seeing a percentage, it will always be exponential. So in this case, this question is exponential. When we are trying to explain, we can just say it has a compounded rate of 3%. Compounded of 3%. 3%. There we go. And we move on to the last question. Oh, is there a question? There is not. The last question is talking about a baseball's height in the air after it's thrown. So again, if I'm throwing a baseball to the air, well, we know that this baseball is going to go up and then eventually it's going to go down. Notice how here we have a parabola. So when we talk about parabola, it is a quadratic function. And for explanation, it's just simply that. It is a quadratic, it is a parabola. The ball's height represents a parabola. Represents a parabola. And that concludes today's notes. Again, it is something very brief. It's just you knowing the difference as to when we have each function. We're going to be having homework for today. It is going to be focusing on this. Tomorrow, you guys will get kind of a review of what we've been learning the last few days, as well as this. And then on Friday, we're going to have a small quiz/check. Since we didn't do anything yesterday, we are going to do something this Friday. Keep in mind, after this week, you guys have one more week to bring your grades up. So please do so. All right. I'll see you guys later. Bye-bye.